Hello, let's see how we can design a hyperboloid in Fusion 360. There are certainly many ways to create a hyperboloid. For example, we can first sketch a hyperbola and then rotate it around its axis to create a three-dimensional hyperboloid. In this video, let's use a basic definition for a hyperboloid. That is, a hyperboloid is a ruled surface. Here's how we are going to play with it. Now look at this line here. This line and the axis here in the middle, they are on the same plane. If we rotate this line around its axis, we are going to get a cylinder. Or you can think of this as extruding the circle all the way up, creating a cylinder. So that works, but it's kind of boring. What if we take this line and rotate it a little bit for a certain angle, say 30 degrees. Now we are going to have a line that looks like this line. It's parallel in space to the axis, but they're not on the same plane. What if we rotate or revolve this line around its axis? Going around, we are going to create a surface, and that surface is called a one-sheeted ruled surface, namely the hyperboloid. By adjusting the angle or the extent to which this line is skewed from the original line, the reference, we can create hyperboloids of different shapes. So in Fusion 360, this is very easy to accomplish. But I realized that there's not an easy way to constrain the angle here between this line and this line. Let's call this angle a skew angle. So we need to use a little bit of trigonometry. Alright, let's look at this picture. Here we have two circles and they are a certain distance away from each other, and let's use a variable for that, or parameter. Height could be 50 or 60 millimeters or whatever you like. And these two circles are away from each other and with a distance of height. All right, that's just the parameter. And the circle can be defined using a center and a diameter. Let's use circle diameter for the as a parameter. And this angle, the skew angle, let's call it, you can call it alpha, you can call it beta, or anything, is the angle between PQ and PW. We need W on the top circle so that we can define or sketch the line, a 3D line PW, and then we rotate PW around to create the surface. All right. So if we use the tangent function, we'll know that the distance between Q and W is actually height times the tangent of skew angle. So that's how we are going to constrain this segment QW. Make sense? All right. So let's go back and see how this can be accomplished in Fusion 360. All right. I'm going to delete everything. Let's go to the very beginning and delete all features after history marker. Please note that I'm using the new GUI, the interface of Fusion 360. It's very similar to the original, and maybe the icons are organized in different ways now. But be patient, you can find the functions you need. The solid, surface, sheet, metal, tools, etc. I'm using design, and under the solid tab, you have all these functions, commands. Under modify, you can create parameters. All right, so you don't have to use parameters. It's just easier if you use them. Let's look at these parameters I have added. The circle diameter is defined, is initiated to be 50 millimeters. The height between those two circles, 60 millimeters. The skew angle, we mentioned that a moment ago, is 38 degrees. It can be any degree. How about 35? Okay. All right. We have all the parameters we need. Let's sketch the first circle. Go to sketch and pick up the plane. How about just the XY plane here? Right. We're going to sketch a circle. You can press C for circle, or go to the menu. Okay, click it and center at the origin. Anywhere if you like. All right. We're going to you can dimension it. D for dimension. Enter the diameter. Circle diameter there. Circle diameter. Okay. All right. So we have a circle there on the floor. Makes sense. All right. We need a point, a reference point. So we're going to place a point somewhere on the circle. Create a sketch point, and anywhere you like. How about here? All right. So that's the point we need. Now we are going to essentially take this circle and raise it to a certain level and a certain distance away from this. To do that, there are certain many ways. Let's try a new plane. How about that? We're going to create a offset plane. Go to construct, offset plane. Offset from where? From the XY plane, or just click the circle here. And we're going to go up or down if you like. How far? Defined by this parameter height. Okay. Height. Enter. Now we have created a new plane that's above this plane. That makes sense? Next, we are going to project the point and the circle onto the new plane. So let's create a new sketch. Go to sketch. Select the new plane, the plane up there. You can name the plane if you want to. There are many ways to do it. There we have select the new plane. We are looking down. We're going to find project, or just press P. Right. Project what? Project the circle. You can see the circle is projected onto the new plane we created above the original circle. And then we're also going to project the reference point. Does that make sense? If we connect these 2 points, we are going to get a line that's parallel to the line connecting these 2 centers of the circle, right? And they are going to be on the same plane. All right, that's okay. If you like, you can connect these 2 points. Let's go to, you can create a construction line, or auxiliary line if you like that term. So connect these 2. Okay, so I'm using three-dimensional sketch right now. That makes sense? Okay, and just for our reference, visual reference, let's also connect the 2 centers of the 2 circles. All right, so that's the axis. Finish sketch at this step. All right, now if we rotate this line around the line that connects the 2 centers, we are going to get a cylinder. That's not a surprise. Now we are going to take this line and rotate it. All right, rotate it around the axis. Okay, for a certain amount. So we have an angle for that. How we can do that? Remember, we have a picture here. We are going to go to the top circle and sketch a point W, so that we can construct this new line PW. All right. Now you can create a new sketch or just go back and edit the original sketch, this one. Alright, edit sketch. We're looking top down at this. Okay, down. Let's go to the very beginning. Alright, so we're working on this plane, the plane that has this new circle. Alright, does it help if I turn off the grid? No. Alright, we are going to create a new line. If you want to, you can use construct line from this point to some point here, and this point has to be at a certain distance from this one if we want a specific angle between this line and that line. See, this line and this line. Right. I found it's at this moment it's not easy to constrain two lines in space. If they are in the same sketch, it's easy. Otherwise, we have to find another way to define it. Right. We're going to constrain this segment. Be careful what we are doing here. Make sure we are really defining the constraining the length of this segment. All right. So it's going to be, as we said, height times the tangent of the function, tangent function, the skew angle, skew angle there. All right, it's about 42 millimeters using the initial angle. Now, that's the point W. We can we need to create a solid line here. Connect these 2 points. That's the line skewed, or turn away from the reference line there. And the angle between these 2 lines is the skew angle. Right now, as we said, it's 35 degrees. I think we are done here. All right, let's take a look. All right, and next we are going to rotate this skewed line around the axis. Okay, the line connecting the 2 centers, or the z-axis in our design, if you like that. They are the same. All right. It turns out we need to use the surface. It used to be called patch. A surface tool. Go to create. You can try revolve. It does not quite work. We are going to use sweep. Sweep what? This profile is this line. We're going to find a path. Okay, a path. That's why we need these 2 circles. You can try either one. They are the same. This one, right? And you can drag it. Okay, you can see we are rotating that line around the axis. Yeah, that's a little bit of that's the process. Does that make sense? Let's just go to distance and try one. One means you rotate this line all around, or all along this path. All right, now we have a new body. It's a surface, and it has no thickness. That makes sense? Let's enable all these planes and look at our work. All right, so maybe hide the plane. So now we have a hyperboloid. If you need any thickness, you can go to create and find thicken it. Thicken what? The surface, and give it a thickness. How about 2 millimeters? All right. So now if you print this out, you're going to get a hyperboloid created by this line that is 35 degrees away from skewed from the reference line. And of course, you can go back to solid and find the parameter and go back. What if I rotate it like say 39 degrees? Oh, 29 doesn't matter. 39 degrees. Click OK. So we have a different hyperboloid. Playing with the skew angle, the angle between these two lines. To what extent this line has been skewed from the reference line, or with reference to the cylinder, which would have been created. We can create whatever we like. That makes sense? All right, let's go back. What if I want something else? I don't want this part anymore. What if I want to add something along this line? So let's just hide the surface. All right. So since we have this line, if you want to create something that's like maybe a stick, right, or pillar, or a long cylinder, you can create a new plane. Let's go back and construct a new plane. A plane along the path, right? Along the path, along this path. Okay, makes sense. We are creating a plane there. You can put it anywhere. How about halfway? If you wanted to really to be halfway, come over here and yep, that's 0.5. It's somewhere halfway along this path, this segment. We are going to leave a plane that's perpendicular to it. See, right? All right. So now we have a new plane defined with reference to this line. Next, let's sketch something on this plane. All right. So we're going to first project. We're going to first project this line onto the plane. So we have a reference point. All right. Let's go to Sketch and click the new plane. You can use the name Plane 4 or just click the plane here. All right. Remember, we're looking at the plane now. It's confusing. But rotate your viewpoint a little bit, and let's project this line onto the new plane. P for project. So now we have a point there, right? Makes sense. Remember, we are creating a new sketch here on this new plane, right? Go back and edit it. I got out the sketching mode just now. Let's go back and sketch. Remember, now we are working in the new plane. So let's, if you like, you can create a, say, a pentagon or anything. Let's do a circle. Right? So let's put a circle here, and diameter if you want to, and dimension it. How about you can use a parameter if you want. Right? How about 5 millimeters thick, or 8, like the diameter of a pencil. All right, and then you can just play with it. Let's how about just give it a little bit of offset. What did I do? Okay, yeah, I press a P. No, I don't want a P. I want to kind of create another circle. Offset this one, and how about around 1.5 millimeters? Okay, so I just created a disc there, like a washer. Why? No specific reason. Just want to play with it. All right. So look at what we have done so far. We created something here. Let's hide the plane in space. Right there, we have a washer there. What if we extrude this washer? Again, there are many ways to do the same thing. All right, let's extrude it. You can use other functions if you want to. Just again, play with it. If it doesn't work, go back and try it again. Let's try extrude. E for extrude or create, and find extrude where? There. Right. Extrude this down, up, right? Or how about direction? Let's try symmetric axis, and try this is how you define the measurement. One direction or the whole thing, doesn't matter. Let's go all the way to, how about here? Stop. So Now we have created it's like a straw, and that's kind of symmetric with respect to design, right? Go as far as you can. 50, negative 50, doesn't matter, positive 50, let's try. Either way is fine. It really depends on your reference, right? Okay. Now, we have a body, essentially, right? That's created with respect to this skewed line. Now, let's go back and make this thing visible. So that's our original surface, right? Now we have a schedule that's aligned with the surface, or the line. So what if I want to rotate this instead of that abstract line there? What if I rotate this thing around the circle or around the axis, right? So let's go. It's essentially a pattern creating process. Let's go to pattern. In our case, we need a circular pattern, right? So let's try the body, right? You can try the feature if you want to. So it's the same feature. This would be the feature, right? If you try the body, that would be the body. Just as long as we know what we are doing. There are many ways to do it. We are going to rotate this body around the axis. Now, the axis is defined by this vertical line or the circle. Either way is fine. All right, how many do we need? 3. It looks like that. That's cool, right? Yeah, that's a very simple hyperboloid structure. And you can always go back along the timeline to the relevant feature, edit this feature. What if we create 16? Yeah, you get something like that. Not bad, right? So now we have a hyperboloid shape. What if we create 60? And it's like, imagine that you're building a structure using 60 straws. You get something like this. You can print it out. I think let's go back to maybe 12 or 10. 12, yeah. So I'm not sure at this moment how they intersect in the middle, but looks like we can. They do intersect. We don't have any holes there. There's a way to kind of extrude from this circle all the way down to create the space. Let's go back to maybe how about 8? Just make sure that we have enough space there. Can we see through? Not quite. Maybe we can go back and change the angle, the skew angle. What if we try 32 degrees? Let's see what happens. Now, do we have? Yeah, looks like we can see through, right? So we can put a pencil in it. Play with it and see how many pencils you can put there. Make sure the hole is big enough. If 8 is too small, try 8.5 or 9. Let's try 12. Can we all see through? Yeah, I see there's something there. Make sure the circle is big enough and the angle is not too big, so that we can put things in it if you want to. All right. So that's essentially how we can create a hyperboloid in Theory 360 using a basic definition for a hyperboloid. A hyperboloid is a ruled surface. That's the rule, right? You rotate this around an axis in space. These two lines, they do not intersect. They do not intersect in space, but they're not on the same plane. Like those two dotted lines, they are parallel. They don't intersect, but they are in the same plane. That doesn't work. If you rotate this, you get a cylinder. All right. So that's all we have. Thank you for watching, and there are, of course, other ways to create a hyperboloid. Thank you.